Yeah, welcome to the lecture on electrical circuit analysis. So, today our topic is to solve the problems on RMS value and average value. Therefore, today lecture is on problems on average value and RMS value. So, last class we have discussed the what is meant by RMS value and what is average value and how to solve this RMS value and average value, and we have discussed small definitions of related to the AC, that is alternating quantities. So, let us solve some problems on this RMS value and average value on this today's lecture. Okay. Coming to the learning objective of this today's lecture is, so first one is to solve the problems on average value and the RMS value, and the next one is to find the average value for the any given waveform. So, how to find out the average value for any given waveform, and the next objective is to find the RMS value for the given waveform. That means, how to find out the RMS value for any given waveform, not only sinusoidal. So, any waveform, it is a sinusoidal waveform or non-sinusoidal waveform, any alternating waveform, how to find out the RMS value and average value. So, we will see in this lecture. Okay. So, first one is now let us solve this. Find out the average value of a full wave rectifier output. Okay. So, what is a rectifier? Rectifier is a device which converts the AC into the pulsating DC. Full wave rectifier which converts the AC into the pulsating DC. Now, this is the average value, that is the average value of the full wave rectifier output. Okay. What is the average value? What is the DC value? Okay. For the full wave rectifier output is, so this is the waveform. The full wave rectifier, see in the question, so he may give this waveform or simply directly ask that find the average value of full wave rectifier. Then you need to draw this waveform. Okay. You need to draw this waveform. So, you have to remember this, the average value for the full wave rectifier is, so 2 cycles. So, in the full wave rectifier, during the 2 positive half cycles, the diodes are turn on. So, that means that during the 2 positive half cycles, the diode will turn on. Therefore, during the 2 cycles, the diode will conduct. Okay. So, this is the waveform. Now, how to find out the average value for the given waveform? Now, what is the waveform? You know that it is sinusoidal waveform. So, it is a current waveform, it is given. So, I is equal to Im sin omega t. Now, I average is equal to, now I said you I average is equal to for symmetrical. Now, see what is the time period here? See, time period is one complete cycle. Complete cycle means the cycle should not repeat. See 0 to pi, okay, 0 to pi the cycle is coming, and again pi to 2 pi, so cycle is repeating. Therefore, we have to take the here the time period is pi, that means t is equal to pi here, 0 to pi is a time period. Therefore, I average is equal to 1 by time period of that waveform, that is a pi integral of 0 to pi I of d omega t. So, therefore, I average is equal to 1 by pi, substitute the I is equal to Im sin omega t. So, I average is equal to 1 by pi integral of 0 to pi. So, I is equal to Im sin omega t d omega t. Therefore, what is sin omega t differentiation? So, sin omega t integration is minus cos omega t. So, minus now write down the 1 by pi outside, Im by pi outside. So, 1 minus cos 2 omega t. Okay, sin omega t is minus cos omega t. So, apply the pi, cos pi is minus 1. So, minus into minus plus 1 minus cos 0. So, cos 0 is 1. Cos 0 is 1. Therefore, minus into plus 1 plus 1 plus 2. Therefore, 2 Im by pi you will get the answer. Okay. So, 2 Im by pi, that means 63.7% of the maximum value. So, the average value for this waveform is 63% of the maximum value. What is the maximum value here? For the peak value, so peak value is here Im. So, 63.7% of the maximum value is the average value for this waveform. Okay. Now, next one. Next question is find the average value for the half wave rectifier. See, for the half wave rectifier, this is the output voltage. So, the DC output voltage or the average voltage. See, DC voltage or DC value or average value, both are same. So, the DC value or average value for the half wave rectifier. See, for the half wave rectifier, during the positive half cycle of the supply, so the diode will turn on. During the negative half cycle of supply, the diode will turn off. Therefore, we are getting the only one cycle, only one positive half cycle, the remaining cycle is 0. So, the remaining half cycle is 0. See, 2 pi is our time period. See, What is the complete cycle means? 0 to 2 pi. So, complete cycle is 0 to 2 pi. Again the same cycle will repeat. So, what is the time period? See, for the given waveform you have to observe the what is the time period. 2 pi is the time period here. So, you know that this is the sinusoidal. So, I is equal to Im sin omega t. So, what is the I average? I average is equal to 1 by total time period, that is 1 by 2 pi integral of 0 to what is the time period again? 2 pi I of d omega t. So, you substitute the I is equal to Im sin omega t, therefore, I average is equal to 1 by 2 pi integral of 0 to 2 pi. So, Im sin omega t. Now, what is sin omega t integration? Again minus cos omega t. Write down the Im by pi outside minus cos omega t. So, minus cos omega t, apply the integral, that is a here see 0 to 2 pi, but 0 to pi it is sin omega t, but pi to 2 pi it is 0. Therefore, I am taking the limit here 0 to pi is Im sin omega t, that is pi to 2 pi it is 0, therefore, we are not considering. Here 1 by 2 pi integral of 0 to pi Im sin omega t plus 1 by 2 pi integral of pi to 2 pi Im sin omega t, but pi to 2 pi the value is 0, therefore, that entire value becomes 0. Therefore, I sin omega t differentiation is minus cos omega t. So, minus cos pi is minus 1, minus into minus plus 1, that is 2 Im by 2 pi. So, 2 will get cancelled. So, Im by pi, that means 31.8% of the maximum value. For this given waveform, the average value or DC value is equal to the 31.8% of the maximum value. Now, the next one is how to calculate the RMS value for the given waveform. Okay, how to calculate the RMS value for the given waveform. See here, so this is the find the RMS value for the full wave rectifier output. So, again same full wave rectifier output, this is the waveform. So, I is equal to Im sin omega t. So, how to find out the RMS value? So, IRMS is equal to square root of 1 by total time period 2 pi. See, total time period is 2 pi here. So, 1 by 2 pi integral of 0 to 2 pi I square d omega t, I square d omega t. So, therefore, 1 by pi integral of 0 to pi Im square sin square omega t d omega t. So, how to write the sin square omega t d? See, Im square is a constant maximum value, you can write it outside. So, Im square by pi you can write outside, and sin square omega t integration, how to calculate this? You write that Im sin square omega t is equal to 1 minus cos 2 omega t, 1 minus cos 2 omega t by 2. Therefore, you can easily solve that 1 minus cos 2 omega t by 2, then you will get this Im by root 2. That means 70.7% of the maximum value. That means, for the given waveform, the RMS value is 70.7% of the Im. But means what you understood from this RMS value and average value means, see here 70.7% of the maximum value, then current is this much current is flowing in a resistor. So, it will produce the some amount of heat, which is equal to the 63.7% of the average value. Okay, 63.7% of the maximum value, that is the average value, when flowing through the same resistor, same amount of heat is generated. Same amount of heat is generated. That is what the average value and RMS value relation. Okay. So, this is what the next to find the RMS value for the off wave rectifier. So, how to find out the RMS value for the off wave rectifier output? Simply, simply same. So, you take the time period 1 by 2 pi integral of 0 to 2 pi. So, see here earlier, here we are taking the up to pi, because here see on 0 to pi. So, pi is the time period here, 0 to pi is the time period, but here 0 to 2 pi is the time period. So, Im is equal to 1 by square root of 1 by 2 pi integral of 0 to 2 pi I square into d omega t. So, that IRMS is equal to the square root of 1 by 2 pi integral of 0 to pi Im square sin square omega t, because root mean square, we have to square the I is equal to Im sin omega t, no. So, Im sin omega t you have to square. So, Im sin omega t whole square is Im square into sin square omega t. Therefore, again your sin square omega t differentiation, it is difficult to find. Therefore, substitute the 1 minus cos 2 omega t by 2. Therefore, you will get that Im by 2. That means 50% of the maximum value. 50% of the maximum value will give you the RMS value for this given waveform. Now, see, that means, see, whenever you allow this current, okay, whenever you allow this this RMS current, So, this current is equal to the, so this here, see here this current 31.8% of the maximum value, same amount of heat is generated. That is what the RMS value and average value. How to calculate the RMS value and average value for the given circuit. Okay. So, we will join in the next class. Thank you.